My dear students, in today's lecture, I will start another topic, that is the effect of feedback on parameter variations and also the effect of feedback on the sensitivity of the control system. So, in my last lecture, already I have discussed what is called a feedback and what is its effect and some examples of feedback, and also what is called control parameter and its variations are explained in my last lecture. Therefore, now it is not required to explain again. So, let us start the today's topic, that is the effect of effect effect of feedback on parameter variations. Then in second, I will discuss the effect of feedback on sensitivity. So let us start. The first topic is, that is the effect of feedback on parameter variations. So to understand this, let us take one example of non-feedback system, that is your open loop control system. In this control system, if we will calculate the parameter variations, and after that I will take another example of feedback control system and I will calculate the parameter variations in feedback control system. If we will compare both the variations, then we can find out what is the effect of feedback on parameter variations. So first let us take one example of, let us take a non-feedback control system that is your open loop control system. There are so many types of open loop control systems are there. Already I have discussed in my previous lecture, that is automobile driving system, then iron, then fan regulator, etc. So let us take the block diagram representation of this open loop control system. This is called open loop transfer function, GS, or forward path transfer function, and this is the input and this is the output. So the transfer function of this, that is TS is equal to C of S by R of S is equal to G of S. Therefore G of S is called open loop transfer function, or it is called forward path transfer function. So let us consider del g of s is equal to change in g of s due to parameter variations. So already I have discussed that is what is called parameter variations, that is the parameter of a control system. The parameter of a control system changes according to environmental conditions. For example, in case of DC motor speed control, when the motor starts rotating due to change in temperature, resistance changes and the parameter also changes. Similarly, in case of PMMC instrument, if we'll take this instrument from colder place to, that is cold place to hot place, then it's the uh, parameter changes, that is resistance of the control spring changes and current also changes. So that is depend upon environmental conditions. So let us consider del gs, that is change in g of s due to parameter variations. So therefore so so del cs, del c of s is equal to corresponding change in controlled output due to change in g of s. So transfer function Ts is equal to c of s by r of s is equal to g of s, or c of s is equal to g of s into r of s, or c of s plus del c of s is equal to g of s plus del g of s into r of s. Which is equal to g of s into r of s plus del g of s into r of s, which is equal to c of s plus del g of s into r of s. Therefore the del cs is this much, that is change in controlled output due to change in parameter, that is del gs is this much. So del C of S is equal to del G of S plus R of S. So this is the change in controlled output. This is the change in controlled output del C of S due to parameter variation, that is del GS into R of S in an open loop control system or non-feedback control system. Now let us consider the feedback control system and find out what is the parameter variations. So now take the feedback control system. Feedback control system. So this is the feedback control system. I am considering here negative feedback because most of the control system uses negative feedback. I will explain this why the most of the control system uses negative feedback instead of positive feedback. So now let us take the negative feedback control system. This is the H of S and this is the feedback R of S. This is the C of S. Therefore, transfer function T of S is equal to C of S by R of S is equal to G of S by 1 plus G of S into H of S. So this is the closed loop transfer function or feedback transfer function. So let us now discuss what is the change in controlled output due to parameter variation. So this implies that C of S is equal to G of S by 1 plus G of S to H of S into R of S. So due to change in parameter variation, now change in controlled output C of S plus del C of S is equal to G of S plus del G of S divided by 1 plus G of S plus del G of S into H of S into R of S. So which is equal to G of S into R of S plus G of S del G of S into R of S divided by 1 plus G of S to H of S plus del G of S into H of S. So this is your C of S plus del C of S. So now let us simplify this equation. Let us simplify this equation. This implies that C of S plus del C of S is equal to G of S into R of S divided by 1 plus G of S H of S plus um, so first we have to neglect this term first. So already we know that the del G of S into H of S is much less than 1 plus G of S into H of S. Therefore, we can neglect this term. So, this implies that C of S plus del C of S is equal to G of S into R of S plus del G of S into R of S divided by this term is neglected. Neglect this term. So 1 plus G of S into H of S. So now this implies that C of S plus del C of S is equal to G of S R of S by 1 plus G of S H of S plus del G of S into R of S divided by 1 plus G of S H of S. So now this is your CS, that is CS is equal to GS into RS by 1 plus GS HS. This we can replace by C of S. So if we will compare both these terms, so del CS, this implies that del C of S is equal to del G of S into R of S divided by 1 plus G of S into H of S. So this is the change in controlled output due to parameter variation in a feedback control system, and this is the change in control output for a non-feedback system. This is for non-feedback system, and this is for the feedback system. Therefore, if we compare both these terms, left side and right side, so this term is divided by a factor 1 plus GSHS, but practically GSHS is much greater than 1. Therefore, we can neglect this one. So del GS into RS, that is change in controlled output, is much smaller than this, because This is divided by a factor gs into hs, which is much greater than 1. So this proves that the feedback uh, reduces the controlled parameter variation or reduces the error in the controlled output. So now let us discuss about the effect of feedback on the sensitivity. So now I will discuss effect of feedback on sensitivity. So before we will go to the chapter, we should know what is called sensitivity. The sensitivity, the sensitivity is the relative change in overall transfer function Ts to the change in G of S. So the sensitivity is the relative change in overall transfer function Ts to the change in G of S. This is called sensitivity of a control system. So sensitivity is equal to percentage change in T of S divided by percentage change in G of S. So this is your sensitivity. So now let us calculate the sensitivity of a non-feedback system. Then we will calculate the sensitivity of a feedback system. If we will compare, then we can find out whether the feedback has effect on the sensitivity or not. So first let us discuss for a feedback control system. So let us consider a small incremental variation in GS. Let us take a small incremental variation in GS. So sensitivity can be found out, that is S G2 T, that is dou T by dou T by T divided by dou G by G, that is your dou G by T. So this is the sensitivity due to incremental change in open loop transfer function G. So find out what is the actual sensitivity of a closed loop control system or feedback control system. So already we know that the transfer function T of S is equal to G of S by 1 plus G of S into H of S. So if we'll take the dou T by dou G, that is dou by dou G of G by 1 plus GH plus GH, G is equal to 1 plus GH minus that is G into 2 by dou G of 1 plus GH divided by 1 plus GH 1 plus GH square. This is the simple derivative I have taken, that is with respect to G. So by taking the differentiation with respect to G, so which is equal to therefore this implies that dou T by dou G is equal to 1 plus GH minus GH divided by 1 plus GH whole square, 1 plus GH whole square. So already we have taken the sensitivity, that is G to T is equal to 1 plus GH minus G of S divided by 1 plus GH square into G by T, that is the transfer function of the closed loop system or feedback control system. So transfer function is G by 1 plus GH. So here this 1 plus GH will be here and GG will be cancelled. Therefore this GH will be cancelled, which is equal to 1 by 1 plus GH. So due to incremental change in open loop transfer function G, so the sensitivity is equal to 1 by 1 plus GH. This is for feedback control system. This is for feedback control system. For feedback system, the sensitivity S equal to 1 by 1 plus GH. Similarly, due to incremental change in G in non-feedback system or non-feedback system, sensitivity is equal to dou T by dou G into G by T. So, in case of open loop control system or non-feedback system, so T, that is transfer function, is equal to G, that is open loop transfer function, is equal to G. Therefore, here we can place, in place of T, we can place G. So here we can place G, dou G by dou G is equal to 1. Therefore, the sensitivity is equal to 1 for a non-feedback system. But for a feedback system, the sensitivity is reduced by a factor 1 plus GH, because here 1 plus GH is divided by 1. Therefore, the sensitivity is very less compared to non-feedback system. Therefore, from this proves that the sensitivity reduces in case of feedback system. Now, let us discuss, due to incremental change in H, that is feedback path transfer function, what is the change in sensitivity? So, similarly, we can calculate due to H to T, that is the sensitivity due to incremental change in feedback path transfer function is equal to minus GH by 1 plus GH, minus GH by 1 plus GH. So, from this, it is proves that the sensitivity is very less in case of feedback path transfer function. So, thank you very much for watching this video.